NEC Article 760 addresses fire alarm systems. Table 760.166 provides the minimum requirements for initiating device circuit cable. Based on the information provided, a cable with one pair, 18 American wire gauge solid conductors, rated for 300 volts, NEC type FPL, and UL listed meets these minimum requirements. It's important to note that NEC Article 760 does not explicitly mandate a plenum rating for vertical cables that interconnect multiple levels in a multi-level building. However, some local building codes may impose additional requirements beyond the NEC, such as specific fire resistance ratings for cables and vertical runs. It is crucial to consult your local building codes to determine if a plenum rating is required in your specific application. While a cable that is one pair, 18 American wire gauge solid conductors rated for 300 volts NEC type FPL and UL listed meets the minimum NEC requirements, it does not inherently possess a plenum rating. If concerns exist regarding fire safety, or if local codes mandate the use of plenum-rated cable, selecting a cable like Belden 6320 UL or a similar cable specifically designed with a plenum rating would be advisable. In summary, based solely on the information provided, a cable described as FPL, 18 American wire gauge solid, 6.5 ohms per meter, data grade meets the minimum NEC stipulations for initiating device circuit cable. Nevertheless, verifying adherence to local building codes remains essential, particularly concerning any supplementary requirements like plenum ratings for cables installed vertically. To elaborate further, understanding the nuances of cable selection for fire alarm systems requires a thorough grasp of NEC Article 760, which governs the installation of fire alarm systems. Firstly, it is imperative to identify the specific type of circuit the cable will serve. In this instance, an initiating device circuit, also known as an addressable panel. Secondly, Table 760.166 within Article 760 outlines the minimum specifications for cables used in fire alarm circuits. This table details factors such as conductor size, voltage rating, and cable type. The information indicates the cable in question features one pair of 18 American wire gauge solid conductors, a 300 volt rating, and is designated as NEC type FPL, signifying its suitability for fire alarm applications. Furthermore, the cable's UL listing confirms its compliance with established safety standards. Thirdly, the question of plenum rating for vertical cables arises. While the NEC does not universally mandate plenum-rated cables for vertical runs connecting multiple levels, local building codes often introduce additional requirements tailored to specific building characteristics and occupancy types. Plenum spaces, typically used for air circulation, demand cables with enhanced fire resistance to prevent the spread of flames and smoke. Fourthly, it is prudent to consult with local authorities and review relevant building codes to ascertain the necessity of plenum-rated cables in the intended application. Factors such as building height, occupancy classification, and the presence of plenum spaces may influence the decision. Fifthly, if concerns persist regarding fire safety or if local codes mandate plenum-rated cables, selecting a cable specifically designed for plenum environments is recommended. Cables like Belden 6320 UL are engineered to meet stringent fire safety standards and offer enhanced protection against flame propagation and smoke emission. Sixthly, in instances where plenum ratings are not mandatory, the described cable, meeting the minimum NEC requirements, may be suitable for the application. However, prudent engineering practice dictates considering the potential benefits of utilizing plenum-rated cables even where not strictly required. Plenum-rated cables offer an added layer of safety and may provide peace of mind in critical life safety systems. Seventhly, the cable's construction details, including its short overall twist lengths and copperline insulation, contribute to its performance characteristics. These design features may enhance signal transmission and overall reliability, particularly in addressable fire alarm systems where data integrity is paramount. Eighthly, the absence of shielding in the cable design suggests it may be susceptible to electromagnetic interference in certain environments. Depending on the installation environment, shielding may be necessary to mitigate interference and ensure reliable communication within the fire alarm system. Ninthly, the overall PVC jacket provides a protective layer against environmental factors and physical damage. However, PVC jackets may not be suitable for all applications, particularly those involving exposure to extreme temperatures or harsh chemicals. Tenthly, in summary, when selecting cable for fire alarm systems, engineers and installers must carefully consider both NEC requirements and local building codes. While the described cable meets the minimum NEC specifications, additional factors such as plenum ratings, shielding requirements, and environmental considerations should be evaluated to ensure optimal performance and safety. The importance of consulting with local authorities and adhering to all applicable regulations cannot be overstated. Furthermore, understanding the properties of the cable is important. The cable in question is specified as having a resistance of 6.5 ohms per meter. This is a measure of the cable's opposition to the flow of electrical current. It's a factor to consider in the overall design of the initiating device circuit, as excessive resistance can lead to voltage drops and signal degradation. In addition to resistance, the cable's capacitance and inductance can also affect signal transmission. Capacitance is the ability of the cable to store electrical charge, while inductance is the tendency of the cable to oppose changes in current. These parameters are generally specified in the cable's datasheet and should be considered when designing the fire alarm system. The cable's data grade designation suggests it is suitable for transmitting digital signals. Addressable fire alarm systems rely on digital communication between the control panel and the initiating devices. Therefore, it's important to use cable that is designed for data transmission to ensure reliable communication. The cable's insulation material, copolene, is a type of polymer that provides electrical insulation and physical protection for the conductors. The insulation material should be resistant to moisture, chemicals, and abrasion to ensure long-term reliability. The cable's unshielded construction means it is more susceptible to electromagnetic interference, as mentioned earlier. Shielded cable may be necessary in environments with high levels of electromagnetic noise. The cable's overall PVC jacket provides a protective layer against environmental factors. PVC is a common and versatile material that is resistant to moisture, chemicals, and abrasion. The jacket should be durable enough to withstand the rigors of installation and operation. It's also important to consider the cable's temperature rating. The cable should be rated for the expected temperature range of the installation environment. Exceeding the cable's temperature rating can damage the insulation and lead to failure. When installing the cable, it's important to follow the manufacturer's instructions and the requirements of the NEC. The cable should be supported properly to prevent strain and damage. The cable should also be protected from physical damage and environmental factors. All connections should be made properly and securely. In addition to the cable itself, it's important to consider the other components of the initiating device circuit. These components include the initiating devices, the control panel, and the wiring devices. All of these components should be compatible with each other and should meet the requirements of the NEC. The initiating devices should be selected based on the specific hazards being protected. The control panel should be capable of monitoring the initiating devices and initiating an alarm when a fire is detected. The wiring devices should be suitable for the application and should be installed properly. Regular inspection and testing of the fire alarm system is essential to ensure its proper operation. The system should be inspected and tested in accordance with the requirements of the NEC and the local building code. Any deficiencies should be corrected promptly. The inspection and testing should be performed by qualified personnel. In conclusion, selecting the correct cable for an initiating device circuit requires careful consideration of the NEC, local building codes, and the specific requirements of the application. While the described cable meets the minimum NEC requirements, additional factors such as plenum ratings, shielding requirements, and environmental considerations should be evaluated to ensure optimal performance and safety. Remember to consult with local authorities and adhere to all applicable regulations.